All right. In chapter 2, we start looking more in depth at matrices. And so I've got here three matrices. And so the first thing we want to talk about briefly is their size. So A is a 2 by 3 matrix, and so is B. So we count the number of rows, and then the number of columns, you count down and then over. C is a 3 by 2 matrix. All right. And then we can refer to individual entries as like for instance, if this is in the A matrix, which we refer to using capital A, then we might use little a to refer to the individual entries, and then we'll use subscripts here. So A sub 2 3 is the entry in the second row, third column. So in this case it would be -2. And so over here B sub 1 2 would be -8. And so we can refer to those kinds of the entries that way. If you've done any computer programming, that should be fairly familiar to you. You know, sometimes we'll just do stuff like this. We'll say, hey, let's let C equal some matrix, and we'll just, pile in the generic C sub ij to say, all right, it's a bunch of entries, and there they are. So anyway, so there's some things about matrices. You can pick up a couple other things. Probably you're pretty familiar with this. The first thing we want to look at is operations with matrices, basic arithmetic operations, addition, subtraction, and multiplication. We don't divide matrices, so we might as well throw that one out. We don't do subtraction. But if I wanted to do A plus B, it's pretty simple. You're just going to end up adding corresponding entries. So I would add the 3 to the 2, right, to give me a 5. And then the -1 to the -8 to give me a -9. And then so on. So I'd have 7, I'd have 5, 4, -4. Let's see, that's a 7 there. All right, so matrix addition is pretty simple. It's just entry by entry, corresponding entries. Of course, implied there is that the two matrices have to have the same size. So they have, so every entry in one matrix corresponds to the entry in the other matrix. Subtraction is the same thing. The only thing you got to watch out for is, negating all of those things in B. So for instance, if I want to calculate A minus B, I'm going to go 3 minus 2, minus 1, or -1 minus a -8 turns into -1 plus 8, so 7. 7 minus 0 is 7. 0 minus 5. 4 minus 0. Minus 2, or -2 minus a -2 turns into 0. Right, so again, entry by entry, we've got to have the same size. Those two things are pretty simple. We can also do, before we get to matrix times matrix, we just need to mention we can do a scalar, so just a regular number times a matrix. Happens just as you would predict. 3 times the matrix A, it leads to 9, -3, 21, 0, 12, and -6. And so we can do that. And then we can do, all kinds of combinations of that, right? 7A minus 6B. And we will leave that to the interested student. Okay. But let's take a moment and talk about multiplication. Oh, no. Before we do that, we probably ought to mention we have some basic arithmetic properties that we're used to when we're doing numeric addition that also apply when we're doing addition and subtraction. So by these properties, I mean stuff like, matrix matrix addition is commutative. Pretty easy to see that, since most of these are easy to see, since matrix addition is and subtraction is defined entry by entry. So we have commutativity when we're adding matrices. We also have associativity, right? And a lot of the most basic arithmetic properties apply here. We have the distributive property, right? R times A plus B is the same as R times A plus R times B. I don't think any of those are terribly surprising. We'll write this one down because it's interesting. We could write that little equation, and when we write that, it's kind of misleading. I mean, unless you're careful. This is really like this is a zero, and it's a bold zero, and of course the zero matrix is the matrix full of zeros. And so of course that's the additive identity. We can easily believe that A plus the zero matrix is A, right? So those are some properties with matrix addition. Let's look at matrix multiplication in the next video.